Okay, so here we have our linear modeling assessment, or linear functions rather. This was the third version for this particular class. And I know that workers in a highly technical factory, they work 10 hours a day, where it's believed the fastest worker can produce 500 units per day. And so that means they're doing 500 units per hour is the highest, the fastest worker available. The management believes that the fastest workers work, the more mistakes they make. The rate at which a worker works is measured by P, the number of units produced. So P is units produced in an hour. The number of mistakes M per hour are counted as well. One worker produced 450 units and made 30 mistakes. Well, this here is a coordinate point I can use, so I know it's 450 units is 30 mistakes, so P and M. And another made 10 mistakes but only produced 300 units. So the 300 units makes 10 mistakes. Consider linear modeling of a situation that relates the number of units produced P to the number of mistakes M. And so when we look at our table, we can see already that we have 2 points. We have one point that is 300, 10, and a second point that is 450, 30. And then I also have a table here I can fill out. The 500 comes from this maximum amount that a worker can produce. So the question B is asking us to make the equation. So in order to make the equation, we have to find the slope. And if I read this, it's always going to be the change in y values. So the 30 minus 10 divided by the change in x values, which will be 450 minus 300. When I subtract, I get 20 minus 150, which is 2 over 15. And if I recognize what's going on here, I can see that when I divide these values, oh, I didn't quite get it right. I missed the 0. I add the 0. You can see that this 2 over 15 is equal to 0.133 to three significant figures. And so, now that I have my slope, I can actually find the equation by using y minus y1 is equal to m x minus x1. Well, I know that m is my y value, so it's m minus, and we'll use this top point, m minus 10 is equal to 2 over 15, my slope, x minus 300. And so if I do this computations, I end up with m, I'll subtract this over, I get 2x over 15 minus 2 times 300 divided by 15 is 40 plus the 10. And so I know that, oh, this should be P. This is P. So I know that M of P is equal to 2 over 15P minus 30. And so this is my equation for the model M at P, where the number of mistakes relate to how many products are produced. Okay, and so now it recommends sketching this graph with x values going from 0 to 550 and y from negative 50 to 50. So if I go to my equation, you can see I've already added my equation. I've set my window accordingly, and so when I graph it, I end up with this pretty picture. C part says state the slope. Well, my slope is 2 over 15, which I know is equal to 0.133. And so what that means, if I think about this, I know that m, mistakes, is on the top of this fraction, and the units produced is on the bottom. So what this means that for every increase of 1 unit produced per hour, there is an increase because it's positive of 0.133 mistakes per hour on average. Okay, and so that is what this actually means. And so if I look at this, I can always start with this x value, and I'm always going to, here's my variable, and then because it's positive increase, and then I go to my y value on top. And if you always consider making this sentence in this structure, you'll always be able to interpret the slope well. Okay, so now moving on to D part, it says state the value of the p-intercept. Well, if I look here on my graph, my y value here, this is going to be my p-intercept because p is like my x-intercept, which means my y value is 0. And in this case, that means the mistakes will be 0. So if I take my equation, which is up top, I can see that 2p minus 15, minus 30, has to be 0 for my p-intercept. So to solve that, I get 2p over 15 is equal to positive 30. If I multiply by 15 and divide by 30, I end up with 225. And if I look at my graph, that looks to be about, it looks like I've done that calculation right, even though my graph is approximate. And so what this means, if I have made 0 mistakes per hour, with 0 mistakes per hour, the worker produced 225 units per hour. That's what that intercept means. Moving on to state the value of the m-intercept. Well, this is like the y-intercept in this case, and that means x equals 0, which is our p-value equals 0. I know my equation is 2/15 p minus 30. So if p equals 0, that means m is equal to minus 30. So what does this mean? That if the worker produced 0 units per hour, he made negative 30 mistakes. So does that mean he fixed 30 errors? I'm not sure. I do know that it does not make sense. It doesn't make sense. But that is what this intercept means. And this is often the case with the y-intercept or the m-intercept, is that it doesn't actually make sense to the context of the question, because usually the questions are set up so that it works for a certain range of values, but not for all of them. Okay, continuing along here. Now I want to show that m at 325 is 13.3. So my equation, m at 325, if I plug it in, I know it's 2/15 times my p-value is 325 minus 30. And so if I do this calculation, I go 2 times 325 divided by 15, and then I subtract 30. We can see that it is equal to 13.3. So that means that if a worker produces 325 units per hour, then she will make, she or he will make 13.3 mistakes per hour. That is what that value means. All right, so now G part says determine the number of units if there are 26 mistakes made. So that means if m is equal to 26, what does p equal? Going to my graph, if I go to my graph and make y2 equal to 26, which is my m values, and I graph it, then I'm going to try and find this point of intersection. And so if I go second trace, number 5, enter, try that again. 5, my left bound, my right bound, my left bound, my right bound, enter. And I just lost it, so let me try that again. So second trace, my left bound, my right bound, and so I can see that my point of intersection is P is equal to 420. If you're doing it algebraically, you're solving this equation here times P minus 30, and again you should get 420. Okay, so I wanted to determine how many mistakes were made if there were 390 units produced. So that's asking for M is unknown when P is equal to 390. So I can plug it into my equation. M at 390 is equal to 2 over 15 times 390 minus 30. And when I do this computation, I can go to my calculator. Now if I just trace for when x is 390, I can see that the blue value here is 22. This is going to be 22. Similarly, if I would just go to my calculator and go 2 times the 390 divided by 15, and then subtract 30, you can see that it is 22. And this means there are 22 mistakes when they work for 390. In IPAR says, in practical sense, the range of possible p-values. Well, to do so, we have to go to our stem here, and the p-values are about the products used. And so if I consider what is going on with this, I know that there are 5,000 units per day for 10 hours, so the fastest worker makes 500 per hour. That's the maximum that you're going to have. And so that means that our maximum is going to be 500, but our minimum is going to be 0. They can't make negative, and it's possible that they don't make any units at all. Not probable, but possible. So then, if this is the case between 0 and 500, what are the m values? Well, I can just use my equation that I have, which is mp at p is equal to 215 p minus 30, and use these values to plug it into p to see the range that I could have. And so I know if I plug 0 in, I get negative 30. Well, that's not possible. So I would say 0, I have to have positive mistakes. But my maximum value could be, if I take my 500 and plug it in, if I go to my graph and if I trace 500, I can see that my value here is 36.6 or 36.7 mistakes, which really, we can't have 0.7 mistake. We're going to have 37 mistakes possible. So there's the range of m values. Discuss any limitations. Well, what we are assuming is true is that the mistake per hour is consistent throughout the day. Okay, and that is a big assumption we're making, because we don't actually know if it's true. Is it true that for my first hour of work, I'm probably more alert versus my 10th hour of work? I mean, I'm tired, so I'm going to guess that I'm going to make more mistakes on this 10th hour than the second hour. But this model does not take that into account. And so the biggest mistake that I think, or limitation, is that we are assuming that the mistakes per hour per unit is consistent throughout the day. We're also considering that each worker has the same rate of mistakes. And so we have to realize that this has been averaged to all the hours and all the workers. And those are reasonable assumptions, but they're not going to be actual reality in truth. Switching now to question 2. This is more algebraic in nature, or more functional in sense. So now we're given, I want to make a sketch of this situation, I know, where A is -2, -1. Here's A, -2, -1. And B is 6, 15. So here is B, 6, 15. So here is AB. Fx is the perpendicular bisector of the segment. So if I'm going to be a bisector, I need to find the middle point, and then it needs to be perpendicular. So it's going at a 90-degree angle here. And so that line here is f of x. That's what I'm looking for. So it wants me to find the value of m. That means to find the value of m, I'm going to go 15 minus -1, because it's the change in y values, over the change in x, which is 6 minus a -2, which is 16 over 8. Now, but I want a perpendicular line, and so 16 over 8 I know is 2. The perpendicular line is going to be the negative reciprocal, so it's -1 over 2. I flip it and change the sign. To find the equation of this, I also need this value here, the midpoint, m, I'll call it. And m takes the x values, adds them together, divides by 2. So the average x, and it does the same thing for the y values. It takes 15 plus the -1 divided by 2. And so I get 6 minus 2 is 4, divided by 2 is 2. And 15 minus 1 is 14, divided by 2 is 7. So my midpoint is 2, 7. And this is the point that my perpendicular bisector is going to go through. Because I need, for every single linear equation, I need a direction and I need a point. So now I can just plug these values into my equation. So y minus y1 is equal to mx minus x1. Solving now for this equation, I'm going to multiply both sides by 2. I get 2y minus 14 is equal to -x plus 2 when I distribute the -1. And so 2y is equal to -x plus 16. And so then finally y is equal to -1/2 x plus 8. And this is f of x. This is f of x is 1/2 x plus 8. If I want the x-intercept, well, there's a hint there that says the y value is 0. So 0 is equal to -1/2 x plus 8, which says 1/2 x is equal to 8. And so x is equal to 16 when I multiply by 2. And so my x-intercept, 16, 0. My y-intercept, well, I know from here, the b value is my y-intercept, because when x is 0, I get 8. So I'm going to get f at 0, which is going to be 8. So 0, 8 is my y-intercept. And then finally, the last challenging algebra problem to work with. I'm told that g of x, this function, is equal to f of x. So I say 1/2 x plus 8 is equal to negative, parenthesis x, negative x. I'm going to distribute this -4 in here, so -44 plus 8x, and then plus x plus 9. And so now, if I keep on simplifying, this is a 44. So here I have 9x minus 44 plus x plus 9. I'm going to keep simplifying. So -9x plus 44 plus x plus 9. So I have x. I'm going to subtract the 8. So I'm going to subtract 8 and collect like terms still. So here I get -8x. And here I'm going to get 9 minus 8, that is positive 1, plus 44 is a plus 45. Multiplying both sides by 2 gives me x is equal to -16x plus 90. Bringing this over, and I just realized I lost my negative sign here. Okay, it's -1/2, -1/2. I forgot it here. Negative, 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 which means this is negative. So if I add 16, I get a positive 15x is equal to 90. Dividing it 90 by 15 gives a nice value of 6. And so in solving this, there's messy algebra here, keeping track of your negatives and positives, our x and our y intercept. But I think ultimately you have to get a sense of what this picture is saying to be able to compute this problem. So take time, think carefully about what these words mean and what the picture is going to give you.